Hi everyone! In this video, I'm going to show you how to create a searching algorithm. But first, let us define what is a searching algorithm. Searching algorithms are designed to check for an element or retrieve an element from any data structure where it is stored. In our case, it is a list. One of the most commonly used searching algorithm is the linear search. Let's try to find 8 in this list using linear search. Using linear search, we go through each elements one by one until we find our element. So how are we going to implement linear search as an algorithm? So the problem specification is write an algorithm to get and display the location of a number in a list. Step 1 is start. Step 2, declare variable x, the number we want to locate, and as the maximum number of elements in a list, a as the value of every elements in the list, I initially at 1, meaning to say it indicates the positioning of an element or initially at first place. And then accept a value for x. So let's say it is the number that we want to find. So it can be anything. Just like in our previous example, it's 8. And then step 4, we will check if I is less than or equal to n and x is not equal to a sub I. So add 1 to the value of I and then repeat until one or both condition becomes false. And then step 5, we will check if I is greater than n and then display x is not in the list. Else, display x is located at position I and then stop. Again class, this algorithm takes time to finish. You need to test it until you reach the correct algorithm or until you created a solution that satisfies the problem. So let's just say I want to locate 5, which is the x on this list of numbers, 1, 11, 15, 5, 8, and 20. And would automatically get a value of 6 since the number of elements in the list is 6. A will represent any value in the list, but only I, which is the position of an element, will determine which element is being represented by A. So this is just like the same thing as the previous video from sorting, wherein we named a list, which is A, and then we define the index or position by the variable I. So here we have this list of elements, and then each of this number has a corresponding, let's say, ID. So it's this one, or the first element is a sub 1, second element is a sub 2, third element is a sub 3, and so on up to a sub 6. So here are the columns in order for us to track what would be the value of this variable. So let's say x is 5, of course. So this is the element that we're looking for. And then initially, I is at first place, so that's why it's 1. And then a sub I. So a is the name of the list. Say, for example, in this uh, presentation, a is equals to the list containing these elements. Okay, so a sub I. So I is 1, so definitely it's at first place. Okay, so a sub I, the element for a sub I is 1. And then the number of elements is 6. And then we will check if I is less than or equal to n. So it's in our step 4. So we will check if I is less than or equal to n. So what is I? It's 1. N is 6. So therefore it's yes. Now we will check if x, which is 5, is not equal to a sub I. Of course, it is not equal. So that's why it's yes. So therefore, we will increment the value of I, or we will add 1 to the value of I. So now I is equal to I plus 1. So I is 1 plus 1 is 2. And then as we go on to our algorithm, so I would become 2, a sub I would become 11, n is still 6, same goes for x, it will is still 5. And then I is equals to 2 and n is equals to 6, so it's yes. X is not equal to a sub I, which is 11, so that's why it's yes. We will increment the value of I by 1, so it's become it becomes 3. Now, since I is equals to 3, a sub I now is 15. So it's placed on the third element. N is equals to 6. So we will check if I is less than or equal to n. So I is 3 and n is equals to 6. So it's yes. And then we will check if a sub I or x, which is the element that we're looking for, which is 5, is not equal to a sub I. So a sub 5 or a sub I is 15 and x is 5. Therefore, it's yes. And then we will add 1 to I again. So it becomes 4. Now I is 4, x is 5, a sub I is 5 since the fourth element is 5, and then n is equals to 6 still. So we will check. Is I less than or equal to n? Yes. And then x is not equal to a sub I. X is 5 and a sub I is also 5. So therefore it's no. And we will only repeat this process if both of these conditions are true. But since one of these conditions are false or no, therefore we already found our element. So here in step 5, we will check if I is greater than n. Is I greater than n? No. Then display x is not in the list. But since I is not greater than n, therefore x is in the list. Else, display x is located at position I. So what is I? It's 4. So therefore, x is located at position number 4. And then step 6 is stop. So that's a simple linear search or simple searching algorithm, namely linear search. So there are other searching algorithms like the binary search. It's an efficient algorithm for finding an item from a sorted list of items. So it works by repeatedly dividing in half the portion of the list that could contain the item. So until you've narrowed down the possible locations to just one. So you could search an additional resources from this YouTube link, so you can watch it. But here's an example. Suppose we have 6 elements. So we will arrange them in ascending order, okay, or in increasing order, okay. So we will assign. It could be so we will try to cut them in half, but we have to point the arrow at one element closer to the middle, okay. So it's either 7 or 12, and then we will check if that is the element that we're looking for. Say for example, we're looking for 1. So is 12 the element that we're looking for? It's not. So we will check if the element that we're looking for is less than or greater than 12. Since 1 is less than 12, therefore we will ignore this portion. And then we will point again to the middle of the left hand side of the element. And then we will check, is 6 the element that we're looking for? It's not. And then we will check again if 6 is less than or greater than the element that we're looking for. Since 6 is greater than 1, therefore we will ignore this part of the list. And then we will check, is 1 the number that we're looking for? Yes, it is. So that's the end of our binary search. Another searching algorithm that we could use is the jump search. It is an algorithm used to search for the position of a target element on a sorted data collection or structure. And instead of searching the array element by element, just like a linear search, jump search evaluates blocks of elements. So let's say we have this elements. So we have to look for the element 25. And since there are 8 elements, we will get the square root of 8, which is equal to 2.82, or round it up to 3. Okay, so we will jump 3 elements from the first element. So we will check if the first element is the element that we're looking for. So it's not. And now we will compare if 5 is less than or greater than 25. Since 5 is less than 25, the element that we're looking for, we will jump 3 elements to the right. Okay, so which leads us to 11. Now we will check if 11 is the element that we're looking for. Since 11 is not the element that we're looking for, therefore, we will compare if 11 is greater than or less than 25. Since 11 is less than 25, we will jump again 3 elements to the right, which leads us to 33. We will check again if 33 is equal to the element that we're looking for, which is 25. Since it's not the element that we're looking for, we will check or compare if 33 is less than or greater than 25. Since 33 is greater than 25, we will do a linear search to the left. Okay? So linear search to the left. So just like this one. So we will step 1 move to the left and check if that is the element that we're looking for. Okay, so is 25 the element that we're looking for? Yes, it is. So that's the end of the jump search. So that's all for now. Thank you for watching and see you on the next videos.